fun it is to ride in a one-horse open sleigh, dashing through the snow in a one-horse open sleigh. O'er the fields we...
All right. There we go. I think we're set to go. All right, on the front side of the worksheet, I ask you to find the magnitude of the resultant vector. Victor, find the magnitude and the length, angle of the angle formed by the resultant vector in vector A. What I would take a look at is let's take a look at problem number 3, the bottom left-hand corner. The bottom left-hand corner. So what we have is let's go that way. We have a picture that looks like this, 100 degrees. We have vector x there and vector A. Here, I give you the magnitude of x is equal to 3, and the magnitude of A is equal to 8. And I want to calculate the magnitude of A plus 2x. The magnitude of A plus 2x. Well, the first thing that we need to draw is we need to draw what A plus 2x looks like. Now, it's important that we get a picture down. Once again, as we've talked about time and time again, draw a picture, draw a picture, draw a picture. We want to draw A plus 2 of the x's. Now, if it's not exactly correct or perfect, that's fine in regards to the directions. But if we take a look, maybe, here is my vector A. And we want to add to that vector x. We want 2 of the x's there, to be honest. We want 2 of the x's added. So if you remember back to what we talked about on Tuesday, this is called the tail. This is called the tip. This is where we start. This is where we end. We are going to go the direction from where we start, a length of A. And then we're going to stop. So we're going to start here and we're going to stop when we get to here. So we're here and we're going to stop when we get to here. And from this point right here, we're going to start traveling x. So I'm going to take x and clone that, bring it down. So I'm going to start x, but this is telling me to do 2 of the x's. So I have 2 of the x's there. And we want to still draw in our resultant vector, Victor, because once again, we want to find the result of what is A plus 2x. We want to find the result of that. And if you remember back to what we talked about on Tuesday, this is the shortcut to Grandma's house. This is a Big Bad Wolf's shortcut to Grandma's house. So here's our resultant vector. Victor? Well, A is giving us a length of 8. What would be the length of 2x? Braden, what would be the length of 2x?
Would it be 6?
6, yeah. Because the length of x is a value of 3. So this is 3, and this is 3. So the 2x would be a length of 6. So we have a length of 8. We have a length of 6. We want to find VR, the third side of this triangle. Now this is where we did some work with respect to our angles. We are given here that the angle in between these two is 100 degrees. And what we did basically here to find a plus x is we just slid x down. But this 100 degrees would just continue to slide down. So this is the angle that is still formed here to here is 100 degrees. So if we continue this and continue our line, this here is 100 degrees, which would be this angle here of 100 degrees, which then would tell us within the triangle, what is the measure inside the triangle that's adjacent to this? Molly, what would be the angle that's adjacent to this inside the triangle? If this is 100 degrees, what does this angle have to be?
80 degrees.
80 degrees. So we have an 80-degree angle there. So this is 80. This is the length of 8. This is the length of 6. I want to find VR. So let's find VR by using our law of cosines. So start out your law of cosines, VR squared. At the end will be the cosine of the angle opposite that. So we're going to have the cosine of 80 degrees. So write your law of cosines equation and solve for the law or for VR. VR squared is equal to, and you can use the a squared plus x squared or 2x squared, does not matter. Minus 2 times a times x cosine of 180 or cosine of 80. Or if you want to start throwing the values in, hopefully you become a little bit more comfortable with the law of cosines equation and you can start substituting values in. Where we have the 8 squared plus the 6 squared minus 2 times 8 times 6. And if you have 6 times 8 and 6 squared plus 8 squared, that is fine. Go ahead and solve for VR. And once again, this is just a click-clack exercise at this point. Isaac Wenger, what do you get for VR?
9.13.
9.13. Yes, no, maybe so. Anybody have issues with that? 9.13. And as I talked about before and numerous times, law of cosines, we can type straight in 8 squared plus 6 squared minus 2 times 8 times 6 cosine of 80 degrees. Get your answer, and then you can square root your answer to get your 9.13. The other question I ask you is, what is the angle formed between vector A and the resultant vector? So this is the angle alpha we're trying to find. And what I would typically do is you can use your law of cosines if you want, but the law of sines would also work here. Law of cosines would be guaranteed. Now what I would suggest happens if you use the law of cosines and you get a value that's close to 90 degrees, with your law of cosines, you get like 86, 87 degrees. I would suggest maybe going back to your law of cosines and redoing the problem, refining the angle. But if I already have an 80-degree angle here, I have a big angle already. So we can set up our law of sines. We have alpha and 6. We have 80 degrees here and the 9.13. So set up your law of sines, equate a proportion, and solve for alpha. And please just don't wait for me to write it down. Hopefully you have, you've been around law of sines and cosines enough that this is good practice for us still. And you showed me on the last quiz that you're able to use your law of sines and cosines. So make your application to the law of sines and cosines. So we have the sine of alpha over 6 equals sine of 80 over our 9.13. We're going to diagonal multiply, and if you start using your calculator a little bit more wisely, we have the sine of alpha is equal to 6 times sine of 80 divided by 9.13, which is the answer we just did. What you can do with your calculator, you still have your answer sitting here that's in your calculator, the 9.1285, so on. We can go 6 times the sine of 80 degrees, close the parenthesis, and then divide by your answer. So I can go second and negative sine, which just pulls down my answer from the first line, and hit enter. Now that is what we're going to have to do the inverse sine of. So we have inverse sine of, once again, I can pull my answer down, 40.34 degrees. Once again, it's a little KYC, know your calculator and what it will do for you to make life a little bit easier, so I don't have to continue to type in a bunch of numbers. I could just use my previous line to be able to get an answer. In the bottom right one, we'll set it up. I'm not going to solve the bottom right one. We'll just set up when we have a minus x. We have a here. Whoopsie. We have a, and we have x. Oops. We have 40 degrees here. Now what we want to calculate is we want to calculate the magnitude of a minus x. So we have a subtraction problem here, which once again, I don't like subtraction, so I boom-ching this to be plus a negative x. So we have a plus a negative x. So we're going to travel a first. And then we're going to travel x. Well, if it was just a plus x, that's what this would look like. But what we have here is we have a negative with this x. So what we talked about on Tuesday is when I go the negative x, it just means I'm going to go in the opposite direction. So rather than plus x, which is going upwards to the left, I'm going to go negative x, which is downwards to the right. So this is my a, and this is my negative x. So we then have our resultant vector. is still, let's see, A is given to us as a length of 5. X is given to us as a length of 2. Now, this is not a negative 2. This just still has a length. The magnitude of X is still a value of 2. Now, the question is what's the angle that I need to put in there? Well, if we take a look, this is your A, traveling A, and then we're going down here, the negative X. And the angle that we need to find is this angle right here, which is this angle right here. What is the measure of the angle that connects the A and X? We know this is 40 here. Well, X is going upwards, I'm sorry, this is negative X. Okay, X is going upwards, X is going downwards. And if I would continue these lines, I would have this and this. Now, if you remember back to your fond memories of geometry and Dr. Clark over there in the geometry world, and you started dealing with parallel lines, what we have here is we have parallel lines and we have a transversal. The angle that we're trying to determine is this angle between the A and the X. What does the measure of this angle have to be? Grace, what does this measure have to be?
40.
40 degrees also. This is 40 degrees here. Now, does anybody remember what we call those two types of angles? We have parallel lines cut by a transversal. These are a set of angles in the parallel lines.
Complementary.
No, not complementary. Those would be two angles that add up to 180 or 90 degrees would be complementary.
Is it supplementary then?
No, those add up to 180.
Opposite interiors.
Opposite interior or alternate interior angles. You have opposite interior or alternate interior. Or opposite interior angles. If two parallel lines are cut by a transversal, alternate interior angles will be congruent. If two angles are congruent, then they have equal measure by definition of congruency. So we have a length of 2, a length of 5. I want to find VR, and I know my angle is 40 degrees. So if you have not done it, set yourself up a law of cosines equation to solve for VR. Law of cosines equation to set up for VR. And once again, just don't wait till I write it down. Look at your triangle. Throw in your values. Once again, you've had enough experience with the law of cosines equation. You should be able to throw your values in there. VR squared equals Bennett, what do you give for VR?
3.7 inches.
3.7. Then we want to calculate the angle formed between VR and A. Now I take a look, or this alpha is across from the smallest side. So it should be the smallest angle, so there's no way for this to be an obtuse angle, because we're across from the value of 2, and that's my smallest side. So it has to be the smallest angle, cannot be obtuse. So go ahead, set your law of sines equation up, solve for alpha. Let's move, let's move, let's move. Andrew, you make it in? Cadence, you make it in? Brianna, you make it in? Mia, what do you get for alpha?
I got 20.33 degrees.
That is correct. That is correct. Any other questions on the front side? Once again, your problems that you have for today, the worksheet I have for today, it will look very similar on the front. I just changed some names and numbers to protect the innocent on the front. I just changed numbers. So you have a different problem to look at. All right, problem on the back, 5, 6, or 7. Before I pick one, is there anybody that has a choice? Anybody have one that they get stuck on, they can get, that they want me to work on, or do you want me to pick one? All right, just take a look at number 7. Number 7, a plane travels 80 miles, bearing of 60 degrees, then turns and travels on a bearing of 160 degrees, travels 130 miles on a bearing of 160 degrees. Now, if you look, the plane traveled 200, the distance it traveled is 210 miles. But the actual distance from where he started, the plane started, is not going to be 210 miles. So let's take a look, once again, at a picture of what we're working with here. Once again, bearing is a north reference, so you're rotating off your north. The positive bearing, and everything in bearing is just going to be a positive direction. You don't have a negative bearing. Okay, so all your directions are going to be a positive bearing. You're going to hold Mickey's tail here and swing and rotate the clock 60 degrees. So we're just taking our vector and we're going to rotate it 60 degrees. And this is a total a distance of 80 miles. Now, what we talked about on Tuesday, at this point, it's going to turn and go on a bearing of 160 degrees. So my suggestion to you is at the tip, draw another axis with your north there. This will help you out immensely as you're trying to go through the problems. Because the second one's going to travel on a bearing of 160 degrees for 130 miles. So if we rotate 160 degrees, here, oopsie, let's try rotation. Here is a rotation of 90 degrees, down to here. So I'm rotating from here down to here. If I rotate down to here, this is a rotation of 180 degrees. I'm not going to go a total of 180 degrees, so I'm going to scooch it back a little bit. And this is 160 degrees. And we're traveling 130 miles. And airplanes tend to do this at times. If they see that they have a big weather storm, a big thunderstorms that are there, or snowstorms or whatever, and they want to travel around it, they will travel around it just so they don't have to go through the turbulence of going through a low pressure system or a hurricane. You know, a plane's not going to want to travel through a hurricane. So they're going to travel around it, but they still want to get to a destination. What we want to calculate is we want to calculate our resultant vector. Victor? VR. Once again, we have created a triangle here. And in this triangle, we know two sides. To find the third side, we need to find the included angle of those two sides. So we need to find this angle here. So we can find what VR is. Well, the problem we have is we don't have an entire angle there. We don't know, we're not given this measure. All we're given is our angles of rotation. This is 160, this is 60 degrees. So when we're dealing with finding this angle inside there in the interior, we might have to do it in pieces parts. So we might have to find two little pieces here. Well, the first one is an easy piece to find right here. If I rotate this 160 degrees, what is this small angle here? Mel, what is this small angle here? If this is rotated 160 degrees, what is this small angle right here? 20 degrees. That is correct. So that piece's part is 20 degrees. The other one is a little bit more involved, but it's still doable. The nice thing about having these axes here is it gives you parallel lines. You have two vertical lines. Here you have two horizontal lines. The vectors act like transversals. And looking at what we just did with the first one, with the alternate interior angles, we can also do that with the second one here. If this is 60 degrees here, what is the measure of this angle right here? Brianna, Genevieve? this, we have parallel lines here, we have a line here, we have a line here, and we have this angle here. We know this is
60.
That's 60 degrees also. Because we have, once again, those alternate interior angles. So we have 20 degrees with this piece part here and 60 degrees here. So the entire angle, what does the entire angle have to equal? Riley, what's the entire angle have to equal?
180.
No, not 180. If this is 60 degrees here, or this is 20 degrees here, and this is 60 degrees here, the entire angle has to add up to equal what?
80 degrees.
80 degrees. So now we know this entire angle is 80 degrees. We know this length is 130, this length is 80. Go ahead and write your law of cosines equation that incorporate this length here, 130, this length here of 80, and the measure of this angle of 80 to find VR. VR squared equals, go ahead and write it out. And solve for VR. Mason, what do you come down to?
140.31.
140.31. And that would be in miles. The next thing we need to do is find a direction, which means you need to take it back to bearing. Okay, what you're looking for is what is my rotation from here all the way down to here. So we're still going to look for an alpha value. This alpha value will be always, here's your original origin. This will be the alpha value that you're going to be looking for. Okay, so go ahead and set yourself up. I have 80 degrees here. This is 140.31 here. Okay, this is my biggest side with the 140.31, so this has to be my biggest angle of 80 degrees. So I can use my law of sines to set up to solve for alpha because I don't have to worry about an obtuse angle in there. Set up your law of sines. Sean, what do you get for alpha?
65.85 degrees.
65.85 degrees is your alpha value. Okay, but now we have to put this back into a bearing mode. And our bearing mode, this is 65.85. That's the angle within the triangle. That is this angle here. We want to put this into a bearing mode, so I want to see what is my rotation from here down to here. Well, the angle within the triangle, this alpha that we calculated, is 65.85. What do we have to do to find this amount of rotation from here down to the bottom? What do you think we should do? Megan, what do you think we should do to find this rotation here? We found this to be 65.85. That's just this angle right here. I want to find this entire angle all the way down, from here all the way down. What could we do?
Add 90.
Not 90. We're going to add something to it, but not 90 degrees. 90 would be the entire angle. I already know from here to here is 65.85. So that is this rotation right here. I want to find this entire rotation all the way down. So what would we add to the 65.85?
Add 60.
Add 60. So we have 125.85 degrees. So my bearing here is 125.85 degrees. You once again just have to have patience as you go through the problem. Okay, going back, getting a picture down, using your law of sines, law of cosines, being able to determine the angle, finding that angle by little, it's like a little puzzle trying to figure out that angle in the inside between the two vectors, Victor. Any other questions you have? On any of the other problems? Once again, the setups for the rest of the problems are very similar to the setup that we just had. It's a matter of, once again, having some patience as you work yourself through the problem. To get your results. Just have to have patience. All right, because I'm not, we have class on Friday tomorrow. Once again, I will send out a remind on the time again. What I would like to do is be able to give you the rest of the time to work on the problems. The worksheet, the additional worksheet I have for you, it looks very similar to this. I just, once again, just changed some numbers in there, so it's a little bit different. But it's relatively the same type of setup, where rather than having an angle of 50 degrees in there that you had to begin with here, you're now dealing with a different angle, or I'm sorry, 30 degrees. Now you're dealing with 50 degrees, and I changed the lengths of the sides. But the setups are very similar to each other. And on the back, it's the same type of problems, but I changed, once again, some measures and some angles in there. So what I'd like to do, once again, unless you have any other questions, to give you the last half hour that you can work on these. So you have a little additional time. Tomorrow we'll come in, we'll go over a problem. If you need me to go over a problem, I'll have a review sheet for you tomorrow. And then Friday or on Monday, we'll have the quiz over vectors and dealing with the idea of vectors, Victor. Anything, questions, anything you want me to go through still? I hope as you see that you have law of sines and cosines, we're still dealing with them. So you still will work with the law of sines and cosines as you go through these problems, which I think we had a good grasp on from our results from the last quiz. Everybody did well in the last quiz with respect to law of sines and cosines, so it's nothing that's different. It's just a matter of you providing the triangle now and you creating that triangle. All right, no questions. I will hang around if you have any other quick questions, but other than that, I'm done. So adios, folks. Have a great day. Go enjoy some snow. Be safe if you're driving around out there. Looks like winter. Hopefully it can hold into having a white Christmas since we haven't had one for the last umpteen years. But other than that, I'm done. If you have questions, stick around. If not, adios. Have a great day.
Thank you, Mr. Gregory.
Yeah.
Mr. Gregory.
Yeah.
Hey, Mr. Gregory.
Yeah.
So tomorrow I won't be around. And I think you're the only class that I have to do tomorrow. So do I have to contact the school, or do I just need to let you know?
Oh, just let me know.
Okay.
Just send me an email. Send me a message.
Okay.
That you're not going to be here, and
Okay.
that's fine.
Okay. All right. Thank you.
Yep.
Bye.